very much, and thank you for the invite to come to speak to you today. So I'm a statistician, and I'm going to find a connection today between myself, the crime author, Agatha Christie, and a Presbyterian nonconformist minister who died about 250 years ago called Thomas Bayes, who is not the person here. We don't know what he looks like. Everyone thought this was Thomas Bayes. It is not, but it's stuck. So it's not Thomas Bayes, but everyone will recognize it as. That's the main link I'm going to be talking about. However, there is, if some of you would like to guess, there's going to be another link that links myself, Agatha Christie, and Thomas Bayes, and it's revealed on the last slide. So see if you can guess what that might be as we go through. So, what I'm going to talk about today is what is statistics. Some of you probably have an idea. It might be a good, positive impression. It might be a less positive impression. So hopefully I'm going to tell you the positive of statistics is absolutely great. And then I'll tell you why I love statistics. And then I'll talk a little bit about some of the basic ideas that I work with in statistics. And then sort of a wrap-up of why it's important in this modern society. So statistics, if you ask someone, they may very well say it's about tabulating numbers, putting them into an Excel spreadsheet. Statistics is the opposite of that. It is not putting numbers into a table. It's actually extracting information from the numbers that might be in a table, which is non-trivial. Data, you might be very easy, you think of a small table, but if you think you might be getting data, it could be images, could be text. All this is information and data that statisticians might be involved with. And from just looking at data, it's very, very difficult to actually make sense of it. And if you get two people, if you look at the same data, they may come with absolutely opposite understanding or interpretation of what it is. So the statistics is being rigorous in a mathematical framework of understanding and extracting information from data, which may not sound that cool, admittedly, but it is. And the reason it is because of Agatha Christie. Now, how many people have heard of Agatha Christie? Yeah, most of you. If you haven't read Agatha Christie, really strongly recommend. I'm an avid fan. Started at the age of 11 and never looked back. And it's her for writing basically crime novels and in particular murder mysteries of why I'm a statistician. So that might confuse you a minute, and I'm going to explain why I'm an Agatha Christie fan led me to being a statistician. So, statistics is like a murder mystery. We have the same things that we're going to do in a murder mystery as we do in a statistical analysis. So if we just look at the right-hand side, so this is my Agatha Christie. Most of them follow this route. You have a murder, and the question is, who did it? Who's the murderer? And you may also have some subsidiary questions like why and how they did it in many of the Agatha Christie cases. So what happens? We have maybe a Miss Marple or Hercule Poirot, Tommy and Tuppence, perhaps a less well-known one that you may not have heard of. They get called to the scene, probably by Inspector Japp, and you look for clues. You go to the murder scene and you try and find clues. So that could be physical things at the murder scene, or it could be questioning suspects and getting information. So all you're doing is gathering information about the murder. Then, if you're Hercule Poirot, you sit in your house or flat in Whitehaven Mansions, you try and piece together all this information. So now you have to make sense so that all the information that you've collected makes sense. And at the end of that process, typically there's a unique solution, and you get Hercule Poirot pulling everyone into a room together and then unveiling who the murderer is, how they did it, and why they did it. That process is exactly the same as the statistical analysis. You start with a question. It might be, does some drug help with the coronavirus that's currently outbreaking? It could be any number of other things. Another problem I'm working on is trying to work out how many people in the UK are living as modern-day slaves. So you start with some question. First thing you have to do is get your data. You go to the crime scene. So you collect data, kind of again done in many different ways. If you think about our drug example, that will often be via a clinical trial. It might be, if you're thinking about the modern day slaves, you might be interviewing people and collecting data from GP surgeries, police records, and so on. So you collect all your data together, and then you have to use your little grey cells to understand what is going on. So this is where you use your statistical analytical tools, and you have to make sense of the data in whatever way you do. And then once you've done that, the critical thing is to be able to understand the output that you've produced. So you don't just come up with a number in maths. You often might have an equation, you have to solve, you come up with a number, and you're happy. Statistics is a part of maths, but it has an extra step. And the extra step is once you have your number, you have to interpret what does that mean. So that is where you identify your murderer. So, think about it now. When anyone asks you what is statistics, you can all say it's simply crime writing. I'm not sure I'm convinced you. Anyone convinced? No. It really is. You're not an Agatha Christie fan. Start reading Agatha Christie and we'll have more statisticians, believe me. Okay, so that's linked me with Agatha Christie. What has it got to do with a 250-year-old nonconformist minister? So, Thomas Bayes came up with sort of an understanding, which is now, many, many years later, this was only really adopted within the mathematical community in the last 40 to 50 years. But there's something called Bayesian Statistics, and it all hinges on this result that Thomas Bayes proposed. And it was actually published after his death back in 1763. And the idea is very, very simple. We're interested in some question that we've just posed, and we may have an initial idea. So when we've gone to the crime scene, we may have an initial idea, before we see the crime scene, of what our understanding is. We might have no understanding, or we might have some understanding from something else. So we have some inbuilt sort of what's called prior information. We go to our crime scene and we collect data. And then given that data, we update our beliefs that we initially had to get our updated understanding of the situation. And Bayes wrote down basically the underpinnings of that understanding, this updating of our information when we observe some data. And it was formalized by someone called Laplace mathematically a few years later. And that's exactly, if you think about it, how our brains work. All the information, our current understanding now as we stand here or sit here, we have in our brains. If we see some new information, we interpret that information in light of what we currently know. So our brains are inherently Bayesian. But you can infer this into statistical analyses. So if you went to the next slide. So let's give a really, really simple example before I wrap up of what Bayesian statistics is. So I might be at home, my son is in the next room, and he shouts out to me that he can see a black and white animal with 4 legs, beginning with the letter C, out through the window. Now, my understanding of my brain is, well, when we start a black and white animal with 4 legs, I immediately think, well, it could be 3 things: a cat, a dog, or a cow. And then I get more information, so those 3 animals fit that category. There's that description, and I get the next information that the animal begins with a C. I would probably automatically discount that it was a dog, because a dog does not begin with the letter C, and my son is too young to know things like collies and so on. So now I have this information. I now have these 2 possibilities, a cat and a cow. I cannot distinguish between a cat and a cow from the information that I have, my data, of what my son has said. But I can use Bayesian statistics to actually come up with one way being more likely than the other. So I live in central Edinburgh. I can't ever remember seeing a cow walking down the street outside my house. I do, however, have seen lots of cats. So the fact that I live in Edinburgh, even though there's nothing in the data, the information I have that discriminates between a cat and a cow, my inherent prior knowledge is it's more likely to be a cat than a cow. So I would conclude it is likely to be a cat. However, if I lived on a dairy farm, I might not conclude it was a cat. I'm more likely to think it's a cow. because cows are passing by all along. But the data cannot distinguish between that. It's this extra information that I have that allows me to do this. And this whole area of statistics is built on this rationale. So, all of us now live in a modern society, and we cannot get away from data. There's a fantastic, it's not a quote from H.G. Wells. So H.G. Wells was another author, and he wrote Journey to the Centre of the Earth, The Time Machine, and I can't remember the other one. So, although this is not a quote from Wells, good, right? Then it's attributed to him. It's a paraphrase that's saying actually statistical literacy is basically now, or is going to be in the future, which is now, as important as literacy. We live in a data-driven society. You may have heard of some recent emerging sciences, or data science and artificial intelligence. The foundational part of those disciplines is statistics. And if we want to live in a data-driven society where we are making informed decisions, statistics is going to become increasingly important. We cannot train enough statisticians fast enough. So, I challenge to you again, if you like science, read Agatha Christie. You might find a parallel with another science. If so, please do come back to me and tell me. I'm not aware of another one that's better than statistics. Challenge yourself, like puzzles, and think laterally. I said, I only realized I loved statistics years after when I thought of this parallel with Agatha Christie. You never know what you enjoy, how it translates into other disciplines. Thanks.